So in the first problem, we have been given an integer and we are being told that this is the rent of like first chef and it would be doubled. So we have to tell the final rent. Basically, it is very straightforward that you are being given an integer and you have to print its double. And I think that everyone would have solved this thing. It is just about input output, take out an input n and print its double. That's it. So shall we move on? Or anybody having any doubt in this? Okay, let's move on to the next one. In the second problem, we have been given one pizza, and what we can do is make a cut. The condition for making a cut is that it should be a straight line and it should pass through a center. And more formally, they have explained it here, but in simple words, it is just this much that you have to make a cut in a line and it should pass through the center. These are the examples of what you can do, and these are the examples what you cannot do. Here you are not passing through the center in the first and third pizza, and in the second pizza it is not a straight line. So I hope that the problem is clear, that in what way we can make the cuts. And the approach is like this. Like by just reading the problem, one thing should come to your mind, that whenever you make the whenever you make a cut passing through the center, it will, like, when the pizza is just a whole pizza, it will make two pieces from one piece. Now every time you make a cut, like it's already having at least two pieces, every time you make a cut except the same cut, it would have like this part and this part will both get into two pieces, will get into two pieces. The next time when you make a cut, again look at this part. Let me use a different pen. This part which you got initially from the first cut, and this cut, whatever cut you make, it will increase the number of uh, slices in your pizza by one on each side. So you could observe something like this, that it is possible for you to have one piece in pizza if you don't make any cut. You can have two pieces in pizza if you make one cut, and it is always possible for you to make like get four pieces, six pieces, eight pieces, 10 pieces, because every time one is gonna be added for both the sides, and so on. So basically, you can have all the even numbers. If n is even, you can always have that many slices for you. And if n is one, then it means that you don't make any cut, and you can make this thing. But if n is odd, you can just try to spend some time to realize this, that it is never gonna be possible, because whatever cut you make, it will introduce exactly two slices every time, except the first cut which you make. Like whatever cuts you make, it will introduce two extra slices. So odd is not possible unless it is one. That's the whole logic. And I think that even this problem would have been done by most of the people. So the logic is just like this, that you take n as input. First of all, you are having multiple test cases, so just run up this loop. And inside the loop, take n as input. If n is 1 or it is even, then the answer is yes, otherwise the answer is no. So is this problem clear, or does anybody have any doubt? In case if you have any doubt, you can write it inside the chat. And if it is clear, then you can just write done inside the chat, so that we will move on to the next problem. Okay, so let's move on to the next problem then. In the third problem, it says that you will be given an integer n and an array of size n, where AI is telling how many chocolates have been given to the ith child. And the distribution was not good. Children were not happy with the distribution. So he decided to redistribute the chocolates in such a way that each child will get at least one chocolate, and the difference of chocolates between any pair of children is not more than k. and we have to tell whether it is possible or not to distribute in this way. So the problem is just like this. You will be given an array of size n, which tells how many chocolates have been given to each child. Now you have to redistribute all these chocolates to the n people in any way you want. The condition is that for any I, ARRI, like for all the I, ARRI should be greater than 0. That is, it should be at least 1. And the maximum of the array, minus the minimum of the array should be less than equal to k. So that's what we are being told in this problem. You could just observe one thing, that the given input doesn't really matter in which order or how many chocolates have been given to anybody. What matters is the sum of this array, which will tell me how many chocolates I have in total, which I have to distribute to the n people. And since I'm told that I have to give at least one chocolate to everyone, I can say that, hey, if sum is less than n, then the answer is definitely no. In case if sum is greater than n, there can be two cases. Like sum might be divisible by n or not. Now, basically, what I want to do is that give one chocolate to everyone first. Once you are done with giving one chocolate to everyone, start giving one more chocolate to everyone one by one until all your chocolates end. So at some point, let's say your chocolates end at this point, these people will have one extra chocolate than these people. Hana, this is going to happen. So if k is greater than equal to 1, and we know that this condition was false, in that case, I can easily say yes. Or if k was equal to 0, then the only possibility for me is that the sum is a multiple of n, or basically sum is divisible by n. In that case, I can distribute equal chocolates to everyone. So it would be for k equal to 0, it would be possible only if sum is divisible by n. So I can easily make up three cases, that first of all find sum. If sum is less than 0, then print no. Else if, in the other case, if sum is divisible by n, or k is greater than equal to 1. In both these cases, the answer is yes. And if not, if both the conditions are false, in that case, the answer is no. So is this problem clear? Should we move on to code, or does anybody have any doubt? Okay, so you are confused about the part k greater than equal to 1. Okay, so what I said was that I wanted to distribute in such a way that max minus min should be less than equal to k. I said that if k is greater than or equal to 1, uh, anything except 0, any positive integer, then what I can do is start distributing chocolates one by one to everyone. I will distribute chocolates one by one to everyone. Now, once I'm done with giving one chocolate to everyone, then I will start distributing again in this way, again in this way, again in this way. So at any time, whenever my chocolates end, I would have given one extra chocolate to these people, which I could not give to these people. है ना? They would have got one extra chocolate than the right people. So max minus min will be equal to 1. I can always do it in this way. And in case if sum is divisible by n, then in that case, max minus min can be equal to 0 as well. This max minus min condition is actually being given to us. This thing, max minus min is less than equal to k, is being given in the problem. The difference of chocolates of any pair of children is not more than k. Difference not greater than k, which means difference is less than k, which is max minus min less than equal to k. So I can just keep it like this. Okay, that's good. So let's move on to the next. Okay, first of all, let's see the code here. We have multiple test cases. That's why I'm having um, this loop. Inside it, I'm taking n and k as input and taking the array as input. You don't really need to store the array. You can skip this part. You just need to find the sum of all the elements in the array. After finding it, you can just run up these three conditions that which we wrote here, that if sum is less than n, answer is definitely no. If it is greater than n, then it will be coming to else if, where we are saying that if it is divisible or k is greater than equal to 1, then just print yes, otherwise print no. So is this problem clear? Should we move on to the next problem? Okay, that's good. Let's move on to the next problem. Uh, this is the fourth problem, and it was the first problem of Dev 2. Here in the problem, we have been told that there will be two integers, x and y, which Alice and Bob have, Alice and Bob. In one operation, in one operation, Alice can choose any of, like Alice can do this operation, like choose x or y, any of these elements, and replace it by GCD of x and y. What Bob can do is something similar. Choose any of x or y and replace that integer, that number, by the LCM of x and y. Right. And our motive is to tell after k operations, what is the minimum possible value of x plus y. This is what we have to find. Uh, yep. Again, like this problem was also pretty intuitive, that you see, Alice has the power of, like Alice can replace a number by GCD. Since we want to minimize it, we would like to use this thing. We would like to uh, make the larger number smaller by using this GCD. And what Bob can do is replace the number by LCM of x comma y. है ना? So Bob will be doing a negative work, or it doesn't do any work. What Alice can do is do either good work for us, like positive work for us. What I mean by positive is that help us in making x plus y smaller, or it does nothing. Let's take an example. For any x and y, let's say if x is a divisor of y, in that case, GCD of x and y will be x, right? In that case, it would be x. So can I say that Alice will choose this y and replace it by GCD, which is x, and your numbers will become x comma x, like x and y both will become x and x. So the sum will be 2 into x. है ना? Whatever GCD we have, you can try to think about it. Let's say the GCD is G. So you can never replace, like you can never reduce your answer less than 2 into GCD. What you can do in the best case is that just replace both x and y by g. In that case, you will have 2 into g. That's what we desire. Just looking up to what we can do. One thing is obvious, that we want to make the numbers equal to g. Let's say if k is a very huge number. K is a very huge number. What you could have done was replace x by GCD of x and y. So, like in the first operation, once Alice chose x and replaced it by g, you could have g comma y as the pairs. Then in Bob's turn, do you think that Bob should choose this number and replace it by LCM, or something else? What do you think? What should Bob do? You can write it inside the chat. What do you think? What should Bob do now? Yes, as we saw that, hey, G is a divisor of Y, or we can say Y is a multiple of G. So it means that LCM of G and Y is Y itself. What we can do is just choose this Y and replace it by the LCM of G and Y. So the pair will still remain to be G and Y. As we saw that Bob was either going to do some bad work for us, make X plus Y larger, or it does nothing. है ना? Here we have managed to get it to do nothing. In the next move, Alice will just choose this Y and replace it by the GCD. So the output will become G comma G. And now it doesn't matter what you do because LCM and GCD both are G. So all the operations will not change anything. So you will get 2 into G as your output. So it makes one thing clear that in the first operation, whatever X comma Y you had, whatever X comma Y you had, you could replace one of the numbers by the GCD and have second one remain the same. In the second operation, you could just replace both of them by G. So if K is greater than equal to 2, the output is definitely 2 into G. This is something we have proved. And what if K is equal to 1? In that case, you can replace only one number. So what do you think? What should I do? If you can choose either X or Y, which one should I choose? If I can choose only X or Y, which one should I choose? I'm definitely going to replace it by G only. I don't have any choice for replacing for the number which I replace. I will obviously choose the larger number because what I want is like what I can do is either have G comma Y or X comma G. And I want to minimize the sum. So I can say that, hey, the sum will be equal to G plus minimum of X comma Y. Whatever it is the minimum sum which we can create in one operation. And that's how you can get to your answer. So is this approach clear? Just write done inside the chat if it is clear. And if anybody has any query, then feel free to ask. Okay, that's great. So let's see the code and then move on to the next problem. The code is also pretty easy for this. This is just the function for finding the GCD. And here you have multiple test cases. For every test case, you take the X, Y, and K as input. You find the GCD of that number. And here we have just if else condition that if a K is actually we can say equal to 1 because it cannot be smaller than 1. If K is equal to 1, then print G plus minimum of X comma Y. Otherwise, just print 2 into G. And I think it would be clear now. Like it's already clear. So let's move on to the next problem. So this is the problem maximize sum. So what this problem says is that you will be given an array. Let me use let me denote the array with this capital numbers, the inputs with capital numbers. So you will be given an array of some numbers of n size. In one operation, what you can do is just like in one operation, what you can do is just choose any two numbers. Let's say this is L and let's say this is R. And what you will do is for all the elements in this range, between these two elements, you will replace them by the minimum of L comma R. And what you want to do is find the maximum sum of array you can obtain. Sum of array you can obtain by applying any number of operations. The operations might be zero, that is, you might not apply any operation, or you can apply even infinite number of operations. Whenever you see that you don't have any constraint on how many operations you can apply, it means that you don't need to worry about whether you apply an operation or not, or how many operations you have been applying. You can just feel free from it. So a clear thing, like a very clear thing, is that for any two numbers, if there is a number which is greater than both of them, or maybe even greater than any of them, let's say this is L, this is R, and this is M. If M is greater than R or M is greater than L, in that case, I will never choose L and R. I will either choose L and M and M and R, like in these two pairs. Either I choose like this, or I might have some better numbers with these either. But one thing is clear that uh, whatever pairs I choose, if there is any number in between which is larger than them, then I will not choose it. I will not decrease the value of M by choosing some smaller L and R. है ना? So one thing which I can very clearly say is that for the array which I have, for any number, it will never get smaller. It will never get smaller, right? It will never get smaller. This is something you can very easily conclude from here, because you are never required to force someone to get smaller. If it is larger, then you can easily just change the operations you have been making. And for any number, the maximum value you can obtain, the max value you can obtain for any number is gonna be the maximum, like the maximum of left and the maximum of right. You just find the maximum number on the left side and on the right side, and the minimum of both these values will be assigned to this number if you apply the operation, right? Right, this is something which will happen and you cannot make any exceptions here. Does this make sense? Please confirm it once. Does this make sense? That for any number, whatever maximum value you can obtain here is, if you pick up the largest value on the left side and the largest value on the right side, then the minimum of them will be assigned in one operation. And you don't have any limit for the number of operations you can apply, so you don't need to worry about it. One thing we have, which has been clear now, is that like whatever larger value you choose here and whatever larger value you choose here, even if there is any larger value in between, which is not going to happen though, but even if it is there, it's not going to affect my answer because I can always divide my operations. So in this case, like when I was there solving it during the contest, by just confirming this part, uh, I concluded that for every element AI, I will just replace it with the minimum of the prefix max till I and the suffix max till I, where prefix max I is the maximum of all elements from A0 till AI. And similarly in suffix max I, it is the maximum of all elements from AI till A of n minus 1. So that's how I first of all did create two integer suffix max and prefix max arrays and replaced all the elements in this way. And then I just calculated the sum of all these values, sum of the array, and that is the answer. Now, for this, I have not really given a very concrete proof. If you wanna do a concrete mathematical proof for this, you can try, but it is not required. And if you spend so much time in doing it during the contest, it will just make you slow. A logical proof is enough. So does this make sense, or does anybody have any query? If you have any doubt, then you can ask it inside the chat. Box. I didn't understand with box. Can you please ask it properly then? Intuition. Okay. Uh, okay, let me repeat it once. I think that your query will be resolved then. That the thing which I concluded at first was that in the operations which I have, one thing which I felt I started with it. The starting point for me was that I just thought that how can I obtain the maximum value for an element? What came to my mind was that I can just pick up the largest value on the left, largest value on the right, and apply an operation in that way. Like you just find the largest value, call it L, find the largest value on right, call it R, and apply the operation on L and R, so that you will get the maximum value here. And then I had a doubt that it will affect all the other values as well, though it's not going to affect it because I'm just picking up the largest value. But still, just to confirm my doubt that will uh, can it have any problem for me? I just concluded it in this way that even if I pick up two elements, because I was confused that I will be applying a lot of operations, so are they independent of each other or not? Uh, since I'm trying to apply independently here. So I just concluded that for any value, if I just pick up L and R on the left and right, and this value is greater than the value on the left or on the right, then I can just apply operations in this way. Basically, you can just skip this part if it is not very clear to you. Like it will go a little longer. Just focus on this part that for any element, the maximum value you can gain is by picking up the largest value on the left, the largest value on the right. You can do this. And if you pick up any value on the left and any value on the right, what will happen is that you are applying an operation here. Now for this part as well, you have been applying an operation. For this part, for every part, you have been applying an operation. I think even that part is also not necessary here, I guess. This much is also already enough for proving it, because in this range, since these are the two largest elements, all the elements will be having the same LNR. So the answer for these elements will definitely be same. For the elements on this part or this part, they will also have some left and right. They will also have some left and right of their own, which will help them to get their maximum value. Now, with this, what I have been doing is that for every value AI, I'm just replacing it with the maximum value I can. Maximum value I can have here. I have been replacing it with that value. So with this, I can conclude that the sum should be maximized now, because I cannot in like have a larger value for any element now. Uh, Maybe this part was confusing. Just skip it out. Just look at this part that for every element, I can find the maximum value it can have by picking up the maximum value on the left, maximum value on the right, and apply the operation on those two elements. In this way, I will find the maximum value for this part, and that left and right will be common for all the elements inside this range. So I don't even need to worry about them being independent or not. I think it should be clear now. Just a small recap once again, since I got it confused at some place. For every element, I will have some left and some right, which will be the left maximum value on the left and maximum value on the right. And uh, in this range, between this range, all the values, since these are the maximum two values on the left and right, all these elements will be smaller than L and R. Otherwise, they would have been chosen as L and R. So these values will be maximized using these L and R. And now similarly for the other values as well, they will also have some specific L and R for themselves. uh, and at the end what I will have is all the values will be maximized as much as they can be. And if I'm able to maximize all the values individually, then the sum of the array will also be maximized. Okay, so let's see the code. uh, in this problem, since we have some larger code, so I'm having a solve function. First of all, what we are doing is just take the number of test cases as input and run up a for loop. In the for loop, for every test case, I'm having a function. In the function, I'm taking n as the array as input, and create the prefix and suffix max arrays. After that, for every element, I'm just replacing it with the minimum of prefix max and suffix max. Notice that prefix max and suffix max have both included the ith element as well. So the ith element will never be reduced. It will never be reduced from what it is right now. And I'm just calculating the sum of all the elements. So the code is pretty simple. I hope it's clear. Shall we move on to the next problem? Um, okay, so let's move on to the next problem then. Lexicographically largest. In this problem, we have been told that we are being given an array A, and we have to form an array B, the largest possible array B, lexicographically largest, such that every element in the array B is less than equal to M. Similarly, the same is true for array A also. And this condition should hold for whatever values I choose for B. This condition should definitely hold that AI is the GCD of the first I elements from array B. And that's it. The problem is this much. So let's see. This is, I think, a good problem. We can call it a good problem. In the problem, we will be given an array A of size n. All the values in the array will be less than equal to M. And I guess it is at least one. Yeah, there would be at least one. And we have to create an array B of size n. The condition should hold that for any element of like any AI, it should be equal to the GCD of B1, like for one based indexing. Let's say let's use zero based indexing. So from zero, B0 to BM, oh sorry, BI. In it should be the GCD of all these values as being written here. And for all such B which satisfy these this condition, I have to find the lexicographically largest one. Lexicographically largest one. And now, if A is a random array, there might be no array B possible for this. So just for that part, they have actually mentioned it explicitly that input A would be such that array B always exists. Like the inputs will be generated such that array B always exists. This is guaranteed. So let's see what we can do. You know that AI should be the GCD of all elements from B0 till B of I minus 1, like comma B of I, है ना? A of I is this part as being mentioned. Can I say that this part is the GCD of A minus 1? And we know that like this is, maybe you can try it with some small examples, or just see it as a formula that you can say if B is the GCD of A1, A2, A3, like this ABC which I am using are not in the problem, just to tell you one thing. if you are having something like A equal to GCD of A1, A2, A3, it is equivalent to saying GCD of A1, A2, and then A3. Like you can write this part in this way as well, by taking the GCD of these two elements and then taking the GCD of this, combining like this. That's what we are going to do here in this exam, in this problem. At this part, we will say AI is the GCD of the combination of B0 to B of I minus 1, which is A of I minus 1, comma B of I. This is what I know, which means that A of I minus 1 and B of I are multiples of A of I. And I can say that A of I minus 1 can be written as something like A of I into some D. This D will be an integer. It might be 1 or it might be something else also. It can be any integer. And similarly, B of I will also be equal to A of I into some other integer. Let's denote it by D dash. है ना? The observation you could make here is that if this A of I, let's say A of, maybe let me take an example. If the array is something like 2, 1, the array A is something like this. For the first element of array B, do you have any choice? You want B0 to be the GCD of, sorry, yeah, you want A0 to be the GCD of B0. So B0 has to be equal to A0, only then it is possible. Only then it is possible. So the first value of array B must be equal to A0. Does this make sense? You can try this out, that there is no other choice. We don't have any other choice. Now for this element, whatever element we choose here, this A1 should be equal to GCD of this A of 0, or maybe let's write it like this right now. B0 and B1. It should be equal to the GCD of the first two elements as being given in the problem. B0 is 2 and this A1, sorry, this A1 is 1. I already know about this B0 and I already know about this A1. With the help of these two numbers, I can determine what are the possible values for this B1. This B1 should be a multiple of A1. It should be a multiple of A, because A1 is the multiple, A1 is the GCD here. So it should be a multiple of A1. And one more thing is that here, maybe let's write A0 here. For this case, here A0 and B0 are same, so you can write anything. But in general, we will be writing something like this: AI equal to GCD of A of I minus 1 and B of I. So in that case, if this B of 1 is equal to 2, in that case, A of 1 and B of 1 will have, sorry, A of 0 and B of 1 will have 2 as the GCD. But we want 1 as the GCD here. We want 1 as the GCD. So we cannot take this 2. This is something you could see. From this, if you try to come up to some better observation, then you could write it mathematically that AI minus 1 divided by AI, basically AI minus 1 was the GCD of all elements from B0 to B of I minus 1, and AI is the GCD of all elements from B0 to B of I. So this AI minus 1 divided by B of A of I is telling me which prime numbers are no more in GCD. As you see that initially we had A0 equal to 2 and then A1 equal to 1. By the way, since it is the GCD of more elements, so uh, any A of I will definitely be either smaller than or equal to A of I minus 1. Either it will become smaller or remain equal. So here you could see that if you find this thing, you will get some number. You will get some integer number. And you can find out the uh, prime numbers in this integer number. Let's say the prime numbers are P1, P2, P3, and so on. Now, if you say this, whatever Bi you had, we said that Bi is equal to Ai into some D dash. है ना? These prime numbers are the prime numbers of D, basically. This is D. So if any of these prime numbers come in D dash, then the GCD of Bi and A of I minus 1, the GCD of AI minus 1 and Bi will not be equal to A of I. है ना? If there is any more prime factor, because you see that if you say X and Y are having a GCD G, it means that X will be something like G into some number, let's say dx, and Y will be equal to G into some number dy. Both of them should be co-prime. If they are not co-prime, then G would not be the GCD. This is something you should be able to understand on your own also. From where you could conclude that if you say A minus 1 divided by AI is D and P1, P2, P3 are the prime numbers in D, the prime factors of D, then all these prime factors should be missing in D dash. It should not come in D dash. This D dash where is something we wrote here. No? Because if it comes, then A1 will not, AI will not remain to be the GCD. So uh, we must have the largest possible value of D dash such that AI into D dash should be less than equal to M, and D dash should not be divisible by any of the prime numbers of D. Basically, GCD of D and D dash should be 1. Both of them should be co-prime. These are the two observations you could notice. Now let's see. Uh, you have some upper bound for this D dash. The upper bound for this D dash is that it should be less than equal to M by AI. This should be an integer which is less than this. Again, now one more thing which you could notice here. It is something like, we will see it later on. Okay, so we will see it later on. Like, this is a good problem. Let me see it right now. This is a good problem. At least with the solution I made, I had a couple of things which will require you to be focused. For the second part, let's check for the second part first. Or maybe see this. What can be the maximum value of this D dash here? Let's see the D. Maybe in this way. Like, I'm getting a little confused in which way should I explain. What I did was to check for D first. What I said was that D is equal to I minus 1 by I, AI. What can be the maximum value for this? The maximum value might be that at some point of time, AI minus 1 is equal to M and A of I is equal to 1 in some test case. So in that case, the maximum possible value of D can be equal to M. And for prime factorizing it, it will take me square root of M. one thing you could notice was that uh, from a0 to a of n minus 1, if you just do this a0 and a of n minus 1, it will also be less than or equal to m. It cannot exceed m, है ना? Because a0 is just reducing slowly and slowly. It is going to just reduce, and a0 by a of n minus 1 can be less than or equal to m. So in total, if you just prime factorize for all the ai minus 1 by a, like in total for all the possible values of I from 0 to n, uh, it will just, the time complexity will be just square root of m. Now, you should spend more time if you're not able to understand it at the moment. But this is something you should be able to solve it. If you are attempting this problem, this is it. You should be able to do at least this much. Okay, so from here, here I found that for every I, we can find D, and then we can find P1, P2, P3, and so on. For every I square root m. No, 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 not for every I. If you combine the time complexity for every I, then it would be square root m. Combination would be square root m, because at first it would be a0 by a1. In the next iteration, it would be a1 by a2. In the next iteration, it would be a2 by a3, and so on. Every time, whatever is happening is this a0 and a1, like a0 is a multiple of a1, so it will be a prime, like it would be a multiple of a1, which means that it would be multiplied at least 2 times, or unless it is equal. And if this number is being multiplied even once or whatever, this gap between them, uh, the product of gap between them cannot exceed a0 by a of n minus 1 at the end. Basically, you can try to prove it yourself. It can be logically proved quite easily. It will be logically proved quite easily, and maybe even mathematically. After that, when we are at this, for every I, we find the value of D. We find the prime numbers. Let's store it inside a set. There can be some other parts also, but what I did was to just store it inside a set of integers. Now, I know that this D dash we had been talking about, let's call it as mx. Basically, let's say mx is the maximum possible value of D dash, maximum possible value of D dash, such that it is co-prime to co-prime with D, and like multiplying it with AI is not exceeding D. So I can say that, hey, initially I will say mx equal to m by AI. M by AI is the maximum possible value I can have for mx. Now I will just I will just say I will just say that check if mx is a multiple, like is co-prime or not, is co-prime with D or not. Okay, so this is some unnecessary part I did. During the contest, I did this unnecessary part. For checking the co-prime, you can even just check for the GCD. So you can just say that, hey, GCD of mx and D, just check this value, and if it is not co-prime, then reduce mx by 1. And just keep reducing it by one by one. And now you can take it as homework or something. You can take it as homework or a challenge that if you try to find the number of times this mx will reduce, the mx and D will be co-prime, how many times will they be? If you try to find it out, it would not be a very large number. And you can just run up a for loop that while mx is not co-prime, is not co-prime, just reduce mx. Just do it. And as soon as it becomes co-prime, you just say that, hey, this bi is equal to ai into mx. Just say this thing. As soon as it becomes co-prime. You know. So does this make sense? That we are trying to have the maximum value. If it is co-prime, you have to make it smaller. You don't have any choice. And at some point of time, when it becomes co-prime, it is the maximum possible value you have got till now. So just take it. Multiply it with ai, as we saw that bi is nothing but ai into some d dash, and mx is the maximum possible value of b dash. And for finding the lexicographically maximum number, we can just multiply that number and store it inside bi. In this way, you will find the max answer basically. This will be your answer. Does this make sense? If it is, then please write done inside the chat. Okay, so let's see the code and then move on to the next problem. In the code, what I did, first of all, we are having multiple test cases. So for every test case, just running up a for loop. Basically running up a for loop to get to every test case, then taking up the input. After that, I initialized the answer variable, like instead of b, I use the word answer, and initialized it with a at the beginning. Because even if you just create answer, it would be a sorry. If you just say that b equal to a, then this b will be a valid array for sure. Then this would be a valid array for sure. By the way, even if you don't initialize it directly like this, it's still fine. After that, I said that just find the d, the um, this d a of I minus 1 divided by ai, and create a set. You don't need to create a set for checking if the elements are co-prime or not. You can just compare, like check the GCD. GCD should be equal to 1. But at the time of contest, I just did this thing, that prime factorize d, and then uh, find the maximum value of mx you can have, and keep reducing mx as long as mx is not co-prime. As soon as mx is co-prime, it is just multiply this into the variable answer, and at the end just print this answer vector, and it will be your answer. So should we move on to the next problem? Is this fine? The implementation can be done in simpler way, and then if you're watching it on YouTube, you will find the implementation with a simpler solution in the description box. Okay, so let's move on to the next problem then. This one is comparatively simpler. Like it is simpler than the last problem. So in the problem, we have been given an array A. We have been given an array A of size n. It will have numbers in the range from 1 to m. In this range, we have to create an array B. We have to create an array B of length n, such that for like for every I, the occurrence of basically the number of times, or let's say the word frequency, the frequency of ai uh, is greater than equal to the maximum frequency, or basically, in other words, there is no bj where j is less than equal to I, such that frequency of bj is greater than frequency of ai. There should be no bj like this. So what you can do, like what you can do for this problem is just don't push any element twice. Like for the first time elements, don't push any element twice. Don't push any element twice. The thing is, let's say in the array, if m equal to 5, 1, 2, 3, 4, 5. Yeah, at this position, 1 has been coming for the first time. So in the array B which you created, till this position, if you have introduced any number more than once, then the frequency of 1 might be less than the frequency of the other number which you have introduced more than once. Let's say if you introduce 2 more than once, twice, then there can be some chance of frequency of AI being less than frequency of some bj. है ना? There can be a chance in this case. So what I did was to just eliminate it. I said that, hey, let me create it properly. I said that I will divide this array which I have in some chunks of size m. And last chunk might not be filled completely. Now for every chunk of size m, for every subarray of size m, I can say that, hey, I will use every element at most once. Every element at most once. है ना? If I used every element at most once, and let's say third element in this chunk, let's say if the third element is 3 in the array A, and in the array B which I'm creating, I have not used anything, like I have not used 3 here or here. Then I will use 3 here. If I have already used it, then I will just pick up any other number here. Something like that. So in that case, I will never have the frequency of bj being greater than frequency of ai. Any bj where j is always smaller than I. This will never happen because frequency of every element, let's say we are talking about this chunk and this array is like, this array is quite huge, but all these elements, let's say if there have been 2 or 3 chunks, every chunk is having the same number of frequency of every element. So you know that the frequency of every element before this point is equal. You don't need to worry about it. You just need to worry about this subarray which you have, this subarray of size n. And here you are not pushing any element more than once. So whatever element you get as AI, you can just say that you can just give the same value. Like you can just, if you have already used it somewhere, then just give it any other value, otherwise give it the same value and do it like this. And this was the intuition. If we talk about the approach of what I did, I said that for the array I have, I will deal with all the chunks separately. Like this one is independent of the other one, and the other one is independent of the other one. For every chunk, let's say, let's take an example instead of just taking anything. Let's take this example, 1, 2, 3, 4. If the array 1 is 1, 2, 3, 4, and m is 4 here, So basically we are just having a chunk of 4 size. 1 2 3 1 2 3 4. Just to make this part. Yeah. You got a 1. You want that frequency of 1 in array A should be greater than the frequency of any other element. So you don't have any other choice. You have to add 1. Then you got a 2. Now you want that the frequency of 2 should not be less than any other frequency. So again you have to just introduce this 2 as well. Then for 3, the next element is 3. So again you have to just push it. For 4, again you have to push it. Let's say in the array 1 2 3 4 there was some 1 coming again, and then 1 coming once again. Then what would I have done is that in the array B, just introduce 1. Then for 2 you don't have any other choice. Then for 3 again you don't have any choice. Then again for 4 you don't have any other choice. Then for 1 you just push 1. Now pushing this 1 once again doesn't make any sense, because let's say you write 1 here and after that there was a 2, then you cannot have a 2 here. No, this was the problem. If you had something like 1 4 1 2 3 4 1 1 2, you cannot have the array B in the same way, but you can have it like this. At this place, since 1 has already come, you know that 1 will never be less, like for any AI, its frequency, whenever AI is 1, its frequency will not be less than the frequency of any other guy. So prefer someone else. Let's say we write 2. Now when we come to 2, you again see that 2 has already come. So again, you don't need to worry about the frequency of 2 getting less than the frequency of any other guy, at least for this chunk. So you will give some other element, let's say 3. In this way, every chunk will have distinct values, all the m values. You know? So it can be logically proved. Concrete proof not required. Concrete mathematical proof. uh, Not required. How am I deciding the size of every chunk? So what I said was that I just want to have all the m elements coming. I just want to have all the m elements coming. So the size must be m. All elements, all variables m coming at exactly 1 in the chunk. So the chunk should be of m size. And this was some sort of constructive algorithm problem. So you will generally see that for constructive algorithm problems, concrete mathematical proof is not required. You just come up with some pattern. You just think about some pattern and try to see that if it can be logically proved, if it is true or not. You get the patterns on the basis of your intuitions or observations in the problem, like whatever intuition you get mainly. So now what we can do is just code it up. For the part of coding, what I did was to take the inputs first for every test case, like initially having multiple test cases. Now for every test case, taking the inputs. After that, creating an answer array. Then creating a set of integers for checking if that element has already come in the chunk or not, and which element to print. Just for that purpose, I created a set. In case if the set is empty, it means that the chunk, all the elements which I had to print first have been printed. So I want to reload my set with all the distinct values. So I will just push up all the values in that case. Otherwise, I will check if I have already printed that, I've already added that element into my answer or not, whatever AI I have. If I have already included that AI into my new array, in that case, I will, this is the case where I have not added actually. This is the case where this element is present in my set, which means that I have not added it. So I will add it to my answer vector and remove it from my set. In the other case, I will just pick up any random value instead of picking any random value, just pick the smallest one, but you can pick up any random value and push it, like just add it to your answer vector and erase it from the set, and then print the answer vector. That's enough. So is this clear, or does anybody have any query? If it's clear, then please write done inside the chat. Okay, yeah, you can write clear as well. Okay, so I think then we can end the session. And for the people who have been watching it on YouTube, um, please consider liking the video and subscribing to the channel. And you can fill out the feedback form from the description. You will find it in the pinned comment. Sorry, not in the description, but in the comment section. And thanks for watching the video. Bye bye.